Okay, we're looking at question 13 for the 2024 Tech Active Maths Methods paper. So we're given an equation here for the number of termites in a termite nest. So what we've got is nt is a over 2 plus e to the negative t. We're told that a is a constant, t represents the time in months, and we're told that at first the population was 3 by 10 to the 5 termites. So we'll use that as times 0, and that's what we're going to use to determine what our a value is. So we've got at n of 0, we would have a over 2 plus e to the 0. We're told that that one is 3 by 10 to the 5. E to the 0 is 1, so that will be over 3. So a is going to be 3 times 3 times 10 to the 5. So a will be equal to 9 by 10 to the 5. That was a 1 mark question. We're then going to use that in the second one to determine the number of termites in the nest half a year after the mound became visible. So half a year, 6 months. So we're then going to substitute that into that equation. So n of 6 is going to equal 9 by, oops, I'm just going to rewrite that. N of 6 is 9 by 10 to the 5 over 2 plus e to the negative 6. And we can pop that into our calculator, and that will give us 449,442.97. Now we are asked number of termites, and this is something that comes through this paper quite a number of times. We're going to round that to 449,443 termites. So that's what I particularly noticed throughout this paper, is that they are rounding that to the whole number anytime that you're asked for numbers. And then down here it says express the time as a decimal. So that's where we'll then leave it as a decimal answer. So just be conscious of that as you're doing those exams, because there's in one of the other questions they allocate a whole mark just for changing it to a whole number value. For part C, determine the time in months after the mound became visible for the initial population to increase by 130,000 termites. So what we've got there, then we first need to know, well, what amount is when you've got an extra 130,000. So that means we've got our 3 by 10 to the 5 plus 130,000. And so then that would be 430,000. So we're now finding what would we get, what time is going to give us 430,000, 9 by 10 to the 5 over 2 plus e to the negative t. Now, because this is a Tech Active paper, the quickest way that I would do this is put the 430,000 into my calculator. I always prefer to use the functions rather than numeric solver. And then we've got our 9 by 10 to the 5 on 2 plus e to the negative x. Graphing that, obviously I'll need to change my window to fit that in. And so I'm going to go from 0 to, now we're in months, so maybe 24. My y max, I need to go up to 500,000 to see that graph there. There we go, we can now see it. We can see that intersection there. So I'll just do my intersect, and that will give me at 2.3749. And so we get 2.3749. So we will leave that, we're leaving that one as a decimal. So for that one, we weren't needing a whole number because we were asked for that decimal answer. And we've got the months there. Now this then goes on to another part. So this is quite a long question. Determine a formula for the rate of change. So rate of change means we are going to do the derivative. So we've got n of t is 9 by 10 to the 5 over 2 plus e to the negative t. So doing the derivative there, I'm going to write it as a chain rule format. And then I'll use my chain rule to find the derivative for that. So I've got my 9 by 10 to the 5u to the negative 1, where u is equal to 2 plus e to the negative t. And then my du on dx is going to be, or du on dt in this case, is going to be just our negative e to the negative t. Here we would have negative 9 by 10 to the 5, u to the negative 2, put them back together, and we would get negative e to the negative t times by 9 by 10, and that we've got the negative negatives, so that will become positive. And then we will have our 2 plus e to the negative t, that is being raised to a negative 2. So I can then take that to the bottom. I can also take that e to the negative t to the bottom to make it an e to the t. And on the top, we will be left with the 9 by 10 to the 5 there. So that is our derivative. And then, and they've also told us to do as a fraction, which is implying we need those positive indices. Then we want to determine the rate of change in the number of termites 5 months after the mound became visible. So same again, we do have our graphics calculator because we are in the Tech Active. So I'm going to do the same way where I'm going to put that formula in, and then I'm going to solve for when it is, like use my second trace 1 to get when it's equal to for 5 months. So I'm going to pop in that rule. And graph that, and then I'm trying to find when that is equal to the n of 5, so my value, and I get 1505.87. So again, this is another one where we've got we're rounding to the number of ants per month, so we've got 1506, or sorry, not ants, termites per month. So again, where we're having to round to the whole number.